Okay, I am recording. So, we're looking at how we can use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac over 2a to solve quadratic equations. And we're going to go through some examples right now, which I've given you a template which we're going to use. Why won't you just go full screen? There we go. Okay, so the first example we're going to solve is this one. So can you grab out your first copy of the template that I've handed you? And can you please... They're both the same. And can you please write this equation into the box where it says the equation? When I photocopied the template for you, I got a little bit choppy on the side. The formula's there. It looks like it's almost been chopped off, but it actually is all there. Just make sure you know that that last one is a C. All right, so using the quadratic formula. The first thing I want to state is that I can use this for any quadratic, but if I use it for something that can be easily factorised, I'm making the problem harder than I need to. All right? So we try and use the quadratic formula when it can't be easily factorised. So we're going to add that as our notes. Use when it can't be easily factorised. When you can't do any of the other methods. But more specifically, remember last lesson we had those solving cards and they were all monic quadratic trinomials. You guys solved them. I'll just go back. It was the factorising task cards. You had the 20 task cards. You factorised them pretty quickly. I think Liam got through 17 or 18 in the space of 10 minutes, right? So you did that pretty easy. That's sufficient. So my question then is, what type of equations can we not easily factorise? Which ones take us a little bit longer or a bit trickier to factorise?
What's the one after the perfect square? Completing the square. No, the one
so,
like one where it's
not
would be like A.
Yeah, so it's non-monic when there's a number here. So when it is a non-monic trinomial, so non-monic trinomials, and completing the square, if I had a problem that I was solving, boys, if I had a problem that I was solving and they were non-monics or a completing the square problem, I'm probably going to find the quadratic formula more efficient. I'm going to find the quadratic formula quicker. All right? So these types of problems, yes, you can use the crisscross method. Who asked that question? Was that you, Levi? Yep. So this is when we're solving. So crisscross is how we factorise. We're now looking at how we solve an equation when we're trying to work out what x is. So the crisscross is to get you two sets of brackets. This is solving to work out what x is. Okay, so here, these types of factorisation would be quicker to use the quadratic formula. Why am I writing this down? Because these are the kind of notes that you can put in your summary journal to help you know when to use which method. One of the things we haven't done a lot of in our summary journals is make notes to ourselves about when to choose a strategy. We've got lots of notes on how to use a strategy, but not notes about when to use it. Having a comment like this might help you decide. All right, example. How do we actually use this? So our example is to solve 8x squared plus 6x plus 1 equals 0. Okay, first thing we're going to do, we're going to label A, B, C so that we don't mix them up. So this is my A, this is my B, this is my C. I'm going to do one extra thing. I'm going to put little brackets around them because it's important that you take the sign as well. If it was a -6, I have to do it as -6. People often forget the sign. So, step 1, work out what A, B and C is. Step 2, write your rule. I'm going to say write the quadratic formula. All right, Chaz, sing it for me. I'm kidding. Oh no, you were ready to go.
X equals negative b plus or minus the square root of b squared subtract 4ac over 2a.
All right, good. Step 3, once we've got a formula, what do you think we're going to do as our next step? Put the numbers into it, which we call substitute. Perfect. And I'm getting a little bit low on the board, but I'm going to squish it in here. X equals -6 plus or minus the square root of 6 squared minus 4 times 8 times 1 divided by 2 times 8. What do you think I might do as my final step?
How do you know whether to get rid of the square root? How do you know whether to plus or minus the square root of -6? Yeah.
Right, well let's actually work through this and let's see how it plays out, okay? So I've got a -6 at the front or a -6 at the front. I can't do anything with that. I need to work out what's inside the brackets, inside the square root sign before I can go any further. So I can square this, which is 36. So I've got x equals -6 plus or minus the square root of 36 minus 4 times 8? 32 times 1? Divided by 16. Now we can do the square root of 4 divided by 16. Sam, what can I do next?
Get rid of the fraction.
No, I can't get rid of the fraction yet. The reason I can't get rid of the fraction is because square roots are the same as having the power of 1/2. Remember when we did indices, square roots are the same as the power of a half. And BODMAS, we have to do square roots before we can do division. So what am I going to do next?
Get rid of the square root.
What's the square root of 4?
2.
Okay, now back to Angus. Angus, you asked the question, how do I know whether to plus or minus? Levi, you asked the question, how do I know whether to plus or minus? Remember when we've been solving quadratics, how many answers have we been getting? 2. This is actually my 2 answers, just written as one statement. So if I like, I can split this up. One of them's a plus, and the other one is a minus. Okay, so -6 plus 2 is what? -4 divided by 16. -1/4. Yep. And then this one? -6 minus 2?
-8.
Excellent, Sam. -8 divided by 16. And that can be simplified to? Negative 1/2. All right, so my final step, I like to state the two solutions as two separate, clearly different answers, but you can write it with a plus or a minus. Okay, did you fit that onto your little template?
I was kind of just watching.
Right. You can go and check. You're going to the conference room, Angus. You're going to the conference room upstairs in the staff room. Do you know where that is? No. If you go to the library, they'll point you in the right direction. Say you're going to get your immunisation. Going as well, Thomas? Yes, you can go check. Okay, how does that sound? How does that fit?
Good, yeah, all right.
All right, let's try a second one. All right. I'll give you a moment to finish copying that down. And then can you grab out your second template and can you put this equation? Oh, I love that you noticed already, Mitchell, that it doesn't equal 0. Do you have an idea about what you might do there? Do you have thoughts about what you might do there? No? All right, well, let's... Okay. So let's work through this second example. Okay, so Mitchell or Sam, whoever did come up with it first, I'm gonna attribute to Mitchell. The first thing I need you to notice is that this doesn't equal 0. Just like the null factor law, when we're solving quadratics, the first thing we have to do is we have to get it to equal 0. So the first thing I'm going to do is I'm going to rearrange. So I've got the extra step where I'm going to rearrange first. And to rearrange, I'm going to add a 3 to both sides so that my equation becomes that. All right, now we're going to run through the same thing as we did on the last question because it's equal to 0. You have got your template. You can fill it out if you like. Devlin, what is the first step that we're going to take? I did not hear a word you said. You were mumbling a little bit. I'm going to write out the formula. Before I write out the formula, label my coefficients with their names. So which one's A? This one's A. This one's B. Notice I need the minus. And this, oh, I did it in the wrong spot, didn't I? A, B, and C. All right, there's my A, B, and C. Don't do it on that one because you will get the sign wrong for C. Freya, what do I do next? Write down the formula. Excellent. I want you to write down the formula to remember what it is. And I also would like you to write this x equals part as well, because that's a reminder about what the formula does. The formula is finding out what x is equal to. Okay, Mary's not here. Dylan, what do we do next? Substitute. So x equals negative 13 plus or minus the square root of negative 13 squared minus 4 times 12 times 3 divided by 2 times 12. Now, I do not want you to put this into your calculator. If you were allowed to use your calculator, you wouldn't be doing any of this. If you were allowed to use your calculator, at this very first step, you would be typing in solve, comma x, and just doing it on your calculator. Right? Don't potentially make mistakes by hand if you can use your calculator. This method is for when we're solving by hand. And when we're solving by hand without a calculator, we are not allowed a summary journal, which means you have to memorise the formula. Okay, what's negative 13, please, Levi? Two negatives make a? Good, so it's just 13, plus or minus. Right, we've got to work out what is 13 squared. We don't have a calculator.
169.
Thomas is not here. Mitchell, what's 13 squared?
169.
Excellent, it is 169. If you don't know that, you've got to be able to work that out. Minus 4 times 12?
48.
48 times 3? Who's got a strategy for how they do 48 times 3? I can cross.
Would you go 40 times 3 and then 8 times 3 and add?
Right, so options. I could do 40 times 3, 8 times 3, and then add them together. I could do 50 times 3, which is 150, and then subtract 2 times 3. Gets the same answer. Either way, you need to have some strategies for being able to do these calculations without a calculator now. Okay, Jaden. We are going to work out this part in here. We have to do 169 minus 144. Break out your pen and paper if you've got a little side bit of working out, or I can do it on the board with you. Nine take 4. Help him out, Peyton. 9 take 4. 6 take 4. 100 take 100. So it's just 25. Now the reason I'm doing these steps is because I am breaking it down for myself. If I have to do all of this in my head, I'm going to make mistakes if I try and hold it all up here. And if I was going to use a calculator, I actually wouldn't be doing any of it. I would just be going right back to this step using the CAS calculator and the solve function. So you never have to do this with a calculator. You're only ever doing this by hand. All right. Then we take the square root of 25, which is what? Liam's not here, is he? Sam? 5. That was quick. Good. And what have I lost in my working out? X equals. Good. This part here is normally the part where I split it into 2 bits. All right, that's the part where I split it into 2 bits. And 13 plus 5 is what, Zach? Oh, he's not here. Is what, Chaz?
18.
And 18 on 24 simplifies to what?
3 over 4.
Good, because 6 goes in there 3 times, 6 goes in there 4 times. I just divided both by 6. See how you're knowing your times tables and being good with your times tables is going to increase your speed and accuracy. And then 13 take 5 is 8, and 8 over 24 is the same as 1/3. I've divided that by 8, divided that by 8, because I know my factors, I know my times tables. And my two answers are x equals 3/4 and x equals 1/3. Okay, I do want to do one more example, because this one, hopefully I've remembered it correctly. This one gets a little bit ugly, and I want to show you how we set up our example. If you would like another template, I have plenty of them, but it's normally about this time people say, oh, I actually don't want to use the templates, I don't want to glue them into my book, I'm just going to do the working out. Is there anyone who would like a copy of another copy of the template to do their third example? There's 2. I don't know why I gave you 2. Just anybody else like to use a template? Right, I'll give you a moment longer to write that down. I can probably get rid of this first part, can't I? Okay, and it looks like I've got a couple more pens waggling, but it looks like we're nearly done. Where you up to, Lever? That one? What did I have? It was 25. Over 24. Okay. All the names back in. Mitchell, what do I do first? Right, or name our variables. Well, we've got to be a little bit careful here. We're saying name the variables. My variable's actually x. That's the thing I'm trying to find. I'm actually naming the pronumerals. The A, B and C, they're my pronumerals. They are the values in the equation that are represented by a letter. Letter A, letter B, letter C. So technicality there, but I'd prefer we didn't call them the variables, because they could be anything really. Right, so before that, Mitchell, how come I know that I can just label them A, B and C already? Perfect. It's already equal to 0, so I know I can just go, this is A, this is B, this is C. Don't miss those negatives. What do I do after that then, please? Peyton. Substitute them into the equation. And I'm going to write the equation so I do it as many times as possible to commit it to memory. So negative b plus or minus the square root of b squared minus 4ac over 2a. The tune helps. I like the tune. All right, then we're going to substitute in So don't forget your minus signs. Because I've got that minus sign, that is why I add the brackets, just to help me spot it and not miss it. All right. When I've marked your assessments, I notice that occasionally we miss these minus signs or we lose them partway through our working out. When we're thinking about a lot of things, we get muddled. So it's useful to put little things in to help us. Same, I need the brackets around the negative. Minus 4 times 2 times. I'm going to put the bracket around the negative because C is minus 13. Divided by 2 times. I don't need to put the bracket. I'm just going to put times on 2. Okay, what am I going to do next, Scarlett? Or what can I do? What are some of the simple things I can do to start making this easier and break it down? Help me out here. What can I do with these two? Get rid of the brackets. And so 2 negatives become a positive. Awesome. So that's the first thing I can do. What else can I do with this one? Still with you, Scarlett. Negative 8 squared. Eight times 8? 64. Negative 8 times negative 8 is also 64. Good. Okay. Chaz, negative 4 times 2 times negative 13. Which part of that? 104, did you say? Are you sure? Oh, yeah. How did you do it?
Negative 4 times 2.
Yep, which is?
Negative 8.
Negative 8, and then what?
Negative 8 times negative 13, which is positive 104.
Did you actually do negative 8 times 13, because you know your 13's times tables? What was the strategy you used in your head to do that?
10 times 13 and then subtract 2 times 13.
Right, nice. So you did 10 times 13, which, because we wanted 8 times 13. So we did 10 times 13 minus 2 times 13, which is 104. We need those strategies to try and do them quickly because we're doing it without a calculator. And those 2 negatives become a positive 104. All over 4. Okay, what do we do next, please? Zach's still right here. Sam.
Add together the two numbers in the square root.
All right, what is that?
64 and 104.
Which is?
168.
Now, in the last example, we had 13 squared was 169. What number times by itself equals 168? 12.9, roughly, something like that. But it's not an easy number. So what am I going to do with that?
Simplify it.
I'm going to simplify it using what techniques? Surds, right, beautiful. We've got to simplify the surd. Can we simplify the surd? So the quadratic formula part's not hard. The quadratic formula is work out A, B and C, write down the formula, stick the numbers in, simplify. But this is requiring us to use all of our maths numeracy skills to simplify this. So we're simplifying the square root of 168. What number that is a square number goes into 168? Square numbers. 1's a square number. There's no point using 1. What's the next one? 4's a square number. Then we have 9, 16. 25? No?
36, 48,
49? 64? All right. Then we have 81 is 9 squared. 81's not going to go in there, is it, perfectly? So let's work down 64. No, because we need 180 for 60s. 49, it's not going to work. 36, maybe. All right. Let's do, who said no? What did you do?
Just times 36 until I got over 168.
Right, so where did you get to? What were the numbers that were nearby?
72, and I got to 144, and I knew then.
Yeah. So what you did is you did 72 and then you doubled it rather than counting each 36. It's like 36, double it is 72, double 72's 144, another 36 is going to be past it. So you can use those kind of strategies to speed it up. 16? Well, if I do 10 times 16, it's what? 160. Not going to work, is it? 9. 4. Does 4 go into 16?
Yes.
So does 4 go into 160?
Yes.
So if 4 goes into 160, it will go into 168. That's what I do in my head to work out that 4 is my number. So I'm going to do the square root of 4 times, now I'm going to work out 4 times what's 160. 4 times 40, I've got to work out 4 times what's 168. What I do in my head is 4 times 40 is 160, and then I need 2 more 4s. All right? Okay. Then I can take the square root of 4, which is 2. I can't take the square root of 42, and I can't simplify it any further. So that is now my part in the brackets. Okay, what do you notice from there, Devlin? Is there anything that strikes you about this? Kind of stands out. Right, good, but that's kind of what I want you to spot. 8's divisible by 4. What about the 2 and the 4? They both have factors of 2. So think about when we simplify fractions, what do? We look for something that goes into the numerator and something that goes into the denominator. We're looking for the highest common factor. Both my numerator and my denominator have a factor of 2. So we can divide by 2 on the numerator and we can divide by 2 on the denominator. Okay, so divide all of that by 2. I get 4 plus or minus the square root of 42. Divide that by 2 over 2. I can't just divide these ones by 2 because I need to divide the entire top line by 2. I can't just split it up and do that part. All right, last step. I'm just going to split up my 2 answers. And I'm going to do 4 plus the square root of 42 divided by 2. And x equals 4 minus the square root of 42 divided by 2. So we spent most of our time talking about the numbers part, not the actual quadratic formula part. So when you're practicing this today, expect working through that simplification is going to take a little bit of thinking and work. All right? I've definitely spoken long enough, so I would love you to jump into exercise 5J to practice. But before you do, if you're doing the black questions, and I think some of these last ones on the blue questions, there's an extra part called the discriminant. Now, the discriminant's not a priority for Year 10 Advanced Maths. It comes up in Year 11. If you want to know about the discriminant, you can scroll to this slide, click on that, and it'll go through a little lesson link all about the discriminant. What the discriminant does is it basically tells us whether there's one solution, two solutions, or no solutions. All right? If you want some extra help as well, there's some extra videos there. Otherwise, have a go at those exercises and I will roam the room and help the people who need some help.